Push,
You got
I
mentioned
pushed the
again.
button. I pushed the button too. Is it still going?
Yeah, it's still going.
All right.
All righty. This is Wednesday, April the 14th, 2021. This is the monthly SLUUG general meeting. And as usual, our announcements and stuff are in the middle of the meeting. So that'll be about a half an hour roughly from now, 20 minutes, 40 minutes, whatever. So with that, I will turn it over to James Conroy, who is our speaker for the basic tutorial session tonight. And he's going to tell us all about creating functions in the bash shell. So James, over to you.
All right. Can everyone see my screen?
Yes, sir.
Yeah.
Yes.
Fantastic. All right, so bash functions, what are they and why should we use them? So we all have at least one command that we want to shorten or change maybe its default behavior in some way just to make our lives easier.
Well, not only can I see your screen, I can see all the dead pixels that are flashing all over your screen.
Uh-oh.
That's all right.
It's snowing black snow.
It must be on your screen, Stanford.
Your end, Stanford. I don't have a problem.
Go on.
All right, so yeah, so we all have at least one command that we want to maybe shorten or change its default behavior to make life easier. And the usual way people do that is with aliases. Here's some of the usual ones. We want some extra options with ls, or maybe want to make sure that rm does not remove entire directories and important files by mistake, just every time you use it. And the only issue with aliases is they work great. They do what they do, but what you see is what you get. They will only ever do one thing and hopefully do it well, but do that one thing. But your shell that you're sitting in front of right now, it's a programming environment. Let's treat it like one by defining and using some functions. So what is a function in this case? So in the bash context, we can just look at the man page, and it's a object that is called like a simple command and can execute a compound command with its new set of positional parameters.
Excuse me a second, James. Question from the group. Is this slide deck going to be available separately? Or?
Oh, yeah.
Right.
I'll send it into the mailing list afterwards.
Fantastic.
Send it to editor, please.
Can do. Wow, that is way too far. There we go. So functions, they can do everything aliases can do and more. What I really like about them is they can change their behavior based on user input, current directories, environment variables, etc., etc. Anything you can think of that you can string commands together and find conditions for, yeah, you can just redefine built-ins or define a new command to do it that way. To declare, you can just say the function name with some curly brackets and, some parentheses and then some curly brackets, or you can preface it with function and then the function name. These can be shell dependent, so check your local documentation. And here's just a quick example I whipped up. What if I want my shell to tell me when it's the weekend? Because that's something I don't want to have to look up every day. It's long and laborious. So we can just check with date. Hey, what day is it? If it's any of these three, tell me it's the weekend. Otherwise, it's time for me to get to work. And like the man page said, these can accept arguments. They can have all the same positional parameters as shell functions or anything else you can think of. So if you want to do something based on all the arguments or just pass user input into a built-in or another command, you can do that. If you only care about the first argument or the number of arguments, you can recognize those and do things based on that. And one of the great things I like about it is it lets you redefine built-ins. So let's say you want to always list out the contents of a directory when you cd into it. You can do that, but hold on. There is a trick, there is a trap with built-ins. If you just name a function the same as a built-in, you will get, oh, maybe not a fork bomb, but it will just infinitely look up, oh, I'm calling a function. Time to go back to that function definition and see what it's doing. Oh, I'm calling a function. Time to go look up that function, see what it's doing, over and over. So you want to preface your built-in calls with command or built-in, and those will suppress function lookups. Here's an example of one function I use basically every day. At work, there's a bunch of servers I SSH into that might have bash on them, but do not have bash as the default shell. And I'm not a fan of the default shell they have. So I'll just go and check, hey, is bash available on the server? It is or it isn't? Okay, if it is, I want to open up a bash shell with my preferred prompt string. Otherwise, just SSH into it like normal. And if you want these to be persistent, you can define them in basically any of your startup files, your bash rec, your profile, the etc profile or profile directory, and they will be available, just going forward whenever you open up a new shell. That means that, hey, functions can be anywhere. You can really split up a bash recs, your definitions, keep them organized and small and simple. But the bad news is that functions can be anywhere. So let's say you're working someplace and the last guy decided to redefine ls to be something like this. We can all agree that this is not a fun thing to have on your computer. Maybe on someone else's, maybe the new guy's computer you can put it on, but I do not want ls randomly segment faulting me.
All right.
Yeah, so how would you find that? You could go and try a recursive grep throughout the whole file system just to see where it's imported from, but that will take a while, and especially with an example like this, there's not a whole lot here to go on. This is all fairly generic. I don't know how many places define ifs or thens or ls's in Unix somewhere, but I'm sure it's a lot of files and it will take a while to search through anyway. So instead, what I like to do, just if I want to see if a function's there, what it's doing, and just get the definition, declare -f will give you all the functions. You can then give it the function name and it'll get the definition, what it's doing. And then to find where it is, you turn on extended debug with your shell, shop-s, and then you declare capital F and the function's name, and that will get you where it is, the line numbers, what it does, basically everything you can do to fix that issue. And then you can turn it off again. For more information, Tom Ryder has a great blog post on this. Since we all work on the shoulder of giants, I suggest going there for a bit more information and a bit more just examples. He tends to take good features he finds in other shells and creates them in Bash. I think he imported like ZSH's CD into Bash. Questions, comments, concerns?
This is Stan. I've got a comment or two and a couple of questions. I think slide numbers would have been helpful to me to track the questions I'm going to throw at you.
Sure.
Where do you find these functions? Are they strictly in the profile and the bash.bash file, or what?
Yeah. So you can define it in your bash rec, in your profile, or in etc profile. And if I do if I go up and reference. Oh, not capital. So they can also be imported from your bash rec. If you look here, I have an SSH function just overriding the default, and that is in my config directory because I'm importing it at the end of my bash rec. Yeah, I'm looking for anything in that directory and loading it, but you can just keep it in your bash rec.
Okay. The word, next question, the word declare, is that a built-in command? Is it part of the bash, or is it a separate command, or what is it?
I believe it is built in.
Okay.
Yeah, it's built in.
Final question. What's a fork bomb?
A fork bomb, well, let me just demonstrate with what I've got here. If I just define ls to be something like...
I'm not seeing your entire screen.
How about now? Is that better?
Ooh.
Yeah, much.
It's chopping off at the bottom. Can you hit return a couple of times to make it go up? What are you in here?
This is cool retro term because it looks nice, but let's try another one.
That'll work. Start up toward the top and make it a little bigger.
I forget how to make it bigger with this one.
Try the Control Plus on the main keyboard, not the extended key number pad.
I am. And let's start near the top again. Okay, so I am just going to do ls that calls ls-l. I'm redefining it. Then I am going to call it and see what happens. Nothing, nothing, nothing. And pretty soon, or at least it did last time, yep, it killed the terminal because it created just an infinite callback loop to that function, looking over and over again. A fork bomb, I'm pretty sure it's something like is the classic example. Like you create a function that calls itself and another one over and over again, and that can bring down your computer if you run it. So you
I don't think we need for you to demonstrate that particular problem at this point.
Yeah, me neither.
I get the idea. Thank you.
Hey, James, got a different question for you. You use that, your declare defined a bash function that is somewhere else off in the system?
Yes.
In which case, what determines whether you can find it, if it's in the path or in your path? Or
so it does not need to be in your path. If I look at if I go and declare just a function test to echo something, yeah, so hello, it works, but
Maybe go to full screen again, please.
yeah. Sure, let's go get that cool retro term up again. Yeah, so if I try redefining test to be the function, it will run test, it will echo everything like it's supposed to, but path will not find it. I'm not sure what the debug does and how it finds it, but this is loaded in separately and before your path.
So it's probably transient for your shell session, I assume, then, if you haven't saved
Yes.
the file. Okay.
Yes. And Chuck had a question in the chat. Yes, I do mostly use it for the SSH, redefining built-ins. I tend to, the question what do I find it most useful for? It's redefining built-ins. I tend to keep my configuration minimal so I don't get blindsided on the new system. But I do like having SSH set up a couple of things on new systems.
Very nice, thank you.
I'm looking at where you say function test open, whatever the hell that is.
Yeah, curly bracket.
Echo curly bracket, and then hello, close curly bracket, semicolon, another close curly bracket is not matching anything.
Yeah, so I'm pretty sure that for some reason that first curly bracket, closing curly bracket, is counted by Bash as part of the call to hello, and you would need to put the semicolon in front of it. Because if we look at when I called test down here, it echoed hello and the closed semi bracket, curly bracket. Let's test that.
In my years of messing things up, I found that anytime you name something test, you're going to run into problems.
Well, yeah, I forgot completely that there is actually a test binary.
And also a test built in, and I think also.
Well, I think the built-in of the brackets is just it calls to the binary, but yeah. Because it's a good name. Everyone wants to use it.
Yeah.
James, this is Ed. Can you hear me?
Yes, I can.
Yeah. I think, am I correct in that the order of evaluation goes like, isn't it aliases, functions, built-in, and then searches your path? Is that right?
I am not sure. That sounds correct. I know that obviously aliases get called and looked at before built-ins or anything in your path, and it's the same way with the functions. I'm not sure which comes first, though.
Ed, you missed your chance. Instead of saying, "Can you hear me?" you should have said, "Test, test, test."
I didn't want to cause a fork bomb in Zoom.
James, I did a lot with functions a long time ago, so it may be a little old. But as I recall in your example there where you had the semicolon, that has to do with the syntax parser in the shell itself, that if you put those on separate lines, you won't need that semicolon.
I believe you are correct. Yes, you are correct.
What shell are you using?
This is bash.
Okay.
Also true for the old SH, and I believe also true for K shell.
You should be able to do this in all the shells. It's just what's POSIX compliant, what's not. Because I'm pretty sure the function keyword is more of a ZSH or KSH thing, but you can also use it in bash.
So I understand what Rich just said about you need a semicolon before the closing brace. I get that. What happened to the brace before the semicolon? Echo didn't echo it.
Yes, it did. If we go back and demonstrate, semicolon, closing brace, semicolon, closing brace, and hello.
Oh, there it is. Yeah.
Close. The wonders of bash and how it does things.
So this answers half the other question. The function test is precessing, it's coming before the built-in test.
Yes. Because if I let's go and redefine ls. And we're just going to tell it to now every time I call ls, it will be not ls, so I can't actually see what's in my directory unless I say instead. Say command ls.
Is command part of the built-in for bash?
I believe so.
Okay.
Same with the built-in keyword. They both disable function lookups.
Other quick question. Instead of command, can you use \ls to override it?
Looks like not a backslash. But I believe there was another way. I can't remember off the top of my head. Of course, if it's a binary, you can just use the path.
Isn't it a space backslash?
That was the old way of doing it. Use the full path.
Yeah, bin ls. Bin ls.
Yeah.
/bin/ls.
Well, everybody knows that.
Well, I'm a new guy. I don't know that.
Yeah, and that'll tell you, but
doesn't a space backslash and then your thing, doesn't that skip the?
I don't believe so. So space backslash.
Not backslash. I mean space.
Forward slash.
No, no, the other one.
Yeah. Nope.
Okay. Well, I don't know.
And then if you want to find out what it does, that's what the declare -f is for.
I asked you once, what's the declare? Is that a built-in?
Yes, it is.
Thank you.
I don't have any reason to prefer ls over bin ls, but I do know I do prefer bin pwd over pwd because pwd will lie to you.
And now you can make sure that every time you call pwd, it just goes straight to bin pwd. Checks that.
That's because bash has its own pwd built in. Whereas the old shell actually invoked the bin pwd.
Nice.
Can you think of any? I mean, I kind of understand why they did it, but it bothers me. But is there any other command that's built in that overrides a path-based primitive?
I don't know of any.
I don't even know what a cat-based primitive is.
No, path, $path.
Oh, sorry.
Yeah, so the actual binary.
I mean, most of the other things like if and then and else and phi and case and whatever, those are bash commands, not command line primitives.
Since you're running a bash, are you familiar with the command help? There's a whole lot of bash help right there.
And there is also the man page. And I'm sure there's info pages on it too.
Yeah, it's about 64 or 84 screens long, I believe.
40,000 lines, I think.
The old story of be careful what you ask for.
Oh, 50,000.
Or oh my.
So that's
type help true. Since that's on the screen there. Help true.
It always returns true.
That's nice.
Ooh, that is more useful than like declare -- help.
Did I hear Mr. Meyer say before I walked away from my speakers, be careful what you bash for?
I wouldn't put him past it. Put it past him.
I wish I could take credit for that, Stanford.
So it was just my hearing aid.
It's either you or your hearing aid, but I'll take credit for being the inspiration.
James, are you aware of the type command? That's very useful for trying to figure out what something is, if it's a built-in or a function or a command or an alias.
This is the first I'm hearing about it.
Yeah, if you get, which one have you got still as a function?
ls.
ls, try that, see what it does.
ls is alias to ls -- color equals auto. So no. So yeah, functions can be really hard to find, it looks like, unless you have an inkling it is a function and go check all the function names with declare -f.
Well, don't you have to export them or something to make it easier to find them, or some screwy thing?
You don't have to export them, but you can just keep them. They're probably going to be in like the bash rec or maybe the profile. But you can find some crazy configurations where it's imported from who knows where.
Like I'd said before, I haven't used them for a while, but there used to be issues with functions when you invoked additional functions that used, or excuse me, additional shell scripts that used functions. So you had a shell script that invoked another shell script, and you expected those functions to be there. And as I recall, they may or may not be there. I think you had to put them in the bash RC, not the profile, for that to happen. If you put them in the profile, they only occurred in the uppermost
and not the subshells.
Whereas if they were in the RC, they were in the subsequent shells.
Yeah, that makes sense to me.
That's true. Yep.
Yeah. Although if you are making scripts and you're giving them out to other people, put them all in the script file. So that is everything I have. I think we can do one last call for questions.
While people are thinking, we never did mention who your employer is. You care to tell us who's employing you these days, James?
Sure. So right now, I make sure people get their drugs on time. I'm working at Express Scripts.
Somebody needs their drugs.
Oh my.
And that was Stan again. But I work at Express Scripts as part of their event management team, overnights, ensuring the health of the enterprise. And so that can involve a lot of going on to servers. Some of them are, like I said, there'll be Linux, there'll be AIX, there'll be HPUX, and some of them even have Bash.
And that's from an organization which is doing legally making sure people get their drugs on time.
I won't comment about what the secretaries have in their little bowls on their desks. You know, come on by and just take a random one.
Oh my. All right. Well, if there are no further questions, we're going to move on. Once again, this is the Wednesday, 14th April, 2021, the general meeting of SLUUG, the St. Louis Linux Unix Users Group. We have, for those of you who may not have been with us before or not for a while, the structure of our meeting is we usually have two presentations in our Wednesday general meeting. The one is a basic tutorial session on the front end. That's what we've just done. Thank you, James, very much. By the way, I should say that was James Conroy again. And James is our chairman of the Linux SIG with our group. The middle part of our meeting is where we're at now. That's where we do announcements and then a general Q&A session where you can ask a question about anything you want. Has a whole lot better chance of getting an answer if it has something to do with computers, Linux, open source, but we'll get to that in a moment. And then the second part of the third part of our meeting is our main or feature presentation, and that'll go for the rest of the evening, and that'll be coming up shortly. So with that, by way of announcement, somebody have a comment? It sounded like maybe it was an echo of my own voice. Maybe it picked up off somebody's speaker. So, okay. Announcements next week on Thursday is the St. Louis LUUG meeting, Linux User Group meeting. Don't be confused by the calendar. Of course, normally we say that's the third Wednesday of the month. I'm sorry, the third Thursday of the month. But due to the structure of the calendar this month, that would put it tomorrow. And so we just moved it to next week, so we didn't have two meetings back to back, Wednesday and Thursday. So that meeting will be the topic will be IBM Series Z and Linux. Also probably a focus on something called Linux One, which is an IBM product that just celebrated its 5-year anniversary, and so. We'll be having a speaker from IBM who's going to tell us all about the status of Linux. The Series Z boxes are the big mainframe class boxes. And of course, you can containerize things there, put it off in the cloud or your own private cloud on your own machine. So anyway, it should be a good, interesting talk. And you're all welcome to come next week. For those of you who may be new to our group doesn't have any membership dues. Basically, if you show up for any of our meetings twice in a calendar year, you're considered a member. So you can vote. And in the meantime, you can we run a couple of mailing lists. One of them is our Discuss mailing list. That's kind of a continuation of this general Q&A period, and you can just bring up questions in mail and get answers in mail. Everybody sees your questions, answers, comments. So you're certainly welcome to join that. There's also an announced mailing list. Doesn't have much traffic. Basically, it usually only gets maybe one traffic a week, just basically announcing what's going on. So, let's see, other than that, we do two other meetings every month that are three, I guess I should say. One of them is our steering committee meeting. Anybody's welcome to come to the steering committee if you like seeing the sausage being made. And the other two meetings are the newcomer Unix or newcomer Linux meeting. That's originally designed with the idea of somebody who's new to Linux. Basically, the running rule has been whoever has the most basic, simplistic question, that's the thing that gets discussed first, and then they work through the rest of the evening from there. So it makes it very nice and friendly for somebody who considers themselves a newbie. The wonderful thing is many of the people at that meeting have been coming for years and years, and so a lot of them are far from being a newcomer themselves, so they're a good source of comfort and information. So the other monthly meeting is the SLAC meeting, St. Louis Area Computer Club, and that was it's a group that's been around for decades and decades, and basically it's talk about any hardware, even if it's got the old Microsoft operating system on it. You can talk about it and how the hardware interacts with it and why things aren't working, and so we come at it from that aspect of that meeting. With that, let's see. Throw that calendar back up there if you could. I think that was probably Stan who put that up there. Stan, can you put the calendar back up, or was that Lee who was controlling that? While they're getting that, we do maintain a calendar, and the calendar has things other than just our meetings. We certainly put our meetings on there, but basically we put, we used to say it was all local meetings. That was before COVID. And so now, besides local tech meetings in the St. Louis area, I mean, usually it'd have something to do with technology, preferably IT technology. But we've kind of expanded it in the age of COVID. We sometimes pick up stuff that's meaningful for Unix, Linux, open source, or open standards, even if it's not actually being done from here in St. Louis, if it's something that people in our group are interested in. So there's also the number of things in the dark boxes at the top are either things that are all day, or if they start off with a year, or if they start off with some year or some number and an anniversary. There are items of historical note. So, but yeah, if you have any suggestions of things that go on there, by all means, send them to editor@sluug.org, and we'll try and get them on there. One other note or announcement, but we're always looking for more fingers, eyes. If people would like to help maintain the calendar, help send out advertising, something to let people know what we're meeting, what we're doing. Drop me a note or drop it to info@sluug.org, and we'll try and get you lined up. Not that you necessarily have to go to meetings or come in to do anything. It's just somebody has a few minutes, they can spend a week to help out. We appreciate it. So let's see. Stan or Lee, you got any favorite things on the calendar?
Not really, sorry.
Okay. Stan, you may have put that free Linux video training coming up this weekend. You got anything to say about that?
Stan, you are muted, just to let you know.
While Stan searches for
I'm usually muted because I cuss like a sailor, although I'm a retired Army Master Sergeant.
I think that's close enough, Stan.
Okay.
I resemble that remark.
I did take lessons, though. Yes, it's free. IT Pro TV. I must admit that I am a paid annual subscriber. I've been paying for this site for almost going on 5 years now. I really like the videos that they do, especially their non-certification videos, because they give a lot of tips and suggestions and techniques. My favorite thing that I'm going over and over again is a series they call Linux Security Techniques. And it's they get into quite a bit of detail on how to do things. Of course, there are a lot of other websites that do provide free training. But this weekend, they're offering, from Friday, sometime Friday, I'm not sure exactly when, all through Saturday and Sunday. And they said, along with 75 hours of free IT training, they get particular access to these new classes they've got here, the LPIC 1 and on the Series 500, 1 and 2. And those are...
Excuse me, Stan, somebody's got a very loud beep going on. Somebody can figure out who's beeping. Thank you. Continue, Stan.
Well, the issue was that was Stan's audio.
That was Stan, Gary.
No, it wasn't.
Yes, it is, because every time I mute you, it goes away.
Okay. I won't say anything more.
The reason is because he's sharing his screen and he's sharing his audio.
Okay. Anyway, I think we got the general idea. Stan thinks it's a good thing, and apparently it's a free sample this weekend. So dig in and enjoy. So
Hard to say no to free.
That's right. That's right. Anybody have any other announcements that I've missed? By the way, I'm impressed this month. I think I mentioned before, I don't know what it is, but there's a lot of big round anniversary dates in the calendar this month. For instance, on Friday coming up in 2 days, it's actually the 50th anniversary of the FTP file transfer protocol. Hard to believe it could be that old. Last week was the 30th anniversary of Java development starting. So number of historical dates on the calendar this month. So, anybody have any other announcements? Otherwise, we'll go to general Q&A. Hearing none. General Q&A. Anybody got any just general questions, things that they've been working on that blew up in their face, or that are still smoking and smoldering in the corner? Or
this is
Gary,
John.
does 50 years of FTP mean 1961?
Let's see.
Be 60 years. This is Jonathan. I have a question for Lee. Lee, are you there? This is about Pine and.
Yeah, go ahead, Jonathan.
So I went and I couldn't find Pine. I found its presumably successor, Alpine, and installed it on OpenBSD. My question for you is, how are you getting these guys to work? I couldn't get my Alpine to work.
I've been using Pine for 20 years. I've set it up on other systems like Bach. The only thing tricky is you have to know how to link to your incoming mail. Like if you're using local mail, it's one syntax. If you're using an IMAP server, it's a different syntax. If you're using a remote server, it's a little bit different.
Okay, So my question for you, Lee, where did you find Pine? Because I looked in the repository and there is no Pine. There's only Alpine as successor.
But it's the same thing. Alpine, about 15 years ago, the University of Washington had a copyright conflict with the name Pine, so they renamed it Alpine.
Okay, so I've got the right thing installed.
Yeah, that's right.
I don't have my OpenBSD box here. I filled out, they give you a help screen, and I filled out the SMTP and the POP3. I use POP3. I filled it out correctly, and it won't send or receive mail. Do you know what I'm doing wrong? Is there
it's in your SMTP server settings or your inbox path, either way.
Gotcha. Okay.
For POP, you're saying you're doing it, you're popping it?
Yep. The reason I do that, Lee, instead of using IMAP is because I have limited storage capacity, so I have to get that mail off.
Yeah,
Robert,
yeah, no problem.
If I had the, if I was at my open, I'm OpenSUSE tonight because it supports Zoom. I can't get Zoom working in OpenBSD.
Yeah, probably because you don't have a standard window manager. You need something current, GNOME or KDE.
Yeah, I'm using that. I'm using the default one, whatever it is, FVWM.
Yeah.
The old motif thing. Well, I'll just muddle through it. I mean, I agree with you. Alpine is a really nice MUA and a lot more intuitive than Mutt.
Oh yeah, and it does things Mutt won't do. Like, you know, I've got 20 profiles set up on Pine and Alpine, and all I have to do is pick it, and it sets my signature, it sets the return at email and everything automatically. Yeah, and depending on what version you have, you need to look at your SMTP server and your inbox path, and those are different. So just look up, you know, look for help on Alpine and POP3, you know, whether you need authentication or not, and then that's, you know, that's how you figure it out.
Okay, will do.
Stanford, back to your question, comment. If you click on that FTP entry, it says the year was 1971, which I think is 50 years.
Yeah, I do bad math in my head. That's the second time today I've lost 10 years. So I look 20 years younger.
Oh my.
I got
That
a
makes
question.
Shoot.
Long story short, an application I'm using is losing a feature that I actually bought it for. So to replace said feature with another piece of application, I need to set up a SFTP server or FTP over SSH. You guys know, do you have any good guides on how to do that so it doesn't get hacked?
So say that again. I'm not sure I followed it entirely.
So I need to stick an SSH server that only accepts and sends files, aka SFTP.
Okay.
I'm trying to find a good guide on how to go through and make sure that the SSH statement is set up in such a way that I'm going to give the maximum number of headaches to the hackers.
Step number 1, disable password logging in. Only accept SSH keys.
Do you know the other ends? Can you restrict the IPs?
No, because they're going to be my phones.
Ah, okay.
Basically, what's happening is Plex is removing the photo sync feature out of its application, and I'm trying to make it so that they keep on coming up with this photo sync app that will do it. It's like $4, but the options it have is SMB, which I am not sticking an SMB on the internet, SFTP, FTP, and DAV. So the only one I can even think of it being acceptable for me to put it on the internet, especially for my local server that I'm building or rebuilding, is secure FTP or SFTP.
I'm going to suggest a different solution. You can set up SyncThing, and that's peer-to-peer, and you don't need to worry about authentication with SFTP. And I use that to sync files between my computer and my phone all the time.
I think there's actually a jail for that.
What was that, Gary? I think.
Repeat the name of that.
SyncThing.
And it is in the chat, the URL to just the web page.
Okay.
It should be in all your app repositories.
And SyncThing is one of the things that we have listed on our planning schedule report that we'd like somebody to volunteer to do.
I'll do it.
Fantastic. We'll take you, Tyler.
Excellent. I'm going to have to set the bloody thing up anyway, so.
Oh, it takes at most an afternoon.
Cool.
Well, and since TrueNAS has a jail already sitting in the repo, it's probably going to take me less than that. The biggest problem is I need to get my 1 terabyte hard drive for my brother back. I have a new, instead of going from FreeNAS 12 to TrueNAS 13, on my current box, I'm building a new Dell 70 something. It's got like 20 cores, 128 gig of memory. The biggest problem is I got to plug my existing disks into it, except for I have a new set of flash hard drives that I got for like $50 for each tear. So, and my brother's hijacked one of them. So yes, I literally have my new Honey Badger server sitting over on my brother's bench, waiting for its last flash hard drive. Not only that, I went out and got those Oracle flash accelerators, PCIe based SSDs.
Oh wow!
I'm not at Linus Media Group's levels of insanity, but I'm getting there. So 20 cores, 128 gig. Most of that's going to go to the ZFS cache. And about 96 tera of raw disk space. Starting out.
Cool.
Nice, nice.
So
when someone said to secure SSH, you turn off passwords and only allow keys. If you do that, how do you get your public key over to the machine that you're trying to get to?
You use a machine that you already have a key set up from.
Yeah, or
usually
you do that first.
Or well, basically what happens, and the reason I run TrueNAS is I have enough trouble as it is getting things running on OpenBSD. So I throw a jail in there, which is locked down to whatever I tell it can talk to. And then I just set up SSH and export the keys to my share. So while they're on, while I'm local, I say, there's this, go over to the server and pull this file off of it, because I have Solid Explorer, which can go through to the SMB share or the.
Well, I guess I should preface my question by saying, you know, do you just have a limited set of, is the only user just you and I just need to get my keys over there? Or do you have a pool of users and you have to wait till they all get their key over there before you turn off their passwords?
It'll be new, so if I set this up, it will be one user, one general service user that's set up only in the jail to synchronize photos to the server. On the other hand, that because it's like 2 or 3 people at the most, I'll have to set up.
Okay, then I get it, right? If it's just, I just want to enable this one point-to-point connection between this one user and this one server, then you're right. You go in and you set it up and you lock it and you harden it.
Yeah, I'll look at sync thing because Plex is removing the photo sync. The whole reason I paid for the damn thing.
I have a question for Ed Howland about daylight savings time.
Okay.
And I could just hear your ears cringing as I said, daylight savings time.
I don't get that upset at people who say it, but okay, what's up?
So the NPR or whatever, I mean, the news is today that the Missouri General Assembly tried to pass a bill that said we're not going to switch time twice a year anymore, but it won't take effect until the federal government allows it. When did the federal government say that the states couldn't do what they wanted to?
I don't know, because Arizona does the same exact thing.
Yeah, and Hawaii, and used to be Indiana.
Something interstate commerce clause.
Stanford, if you go to that link that I posted on Discuss, it's got another link down at this at the bottom that goes to a whole nother Wikipedia page that explains that the federal government instituted this at the end of during World War I and World War II, and essentially it says, this is how you do it, and that you have the states have the option. Some states have states have the options to opt out of the doggone thing.
Well, I was just listening to it and I was driving and trying to pay attention to the traffic around me. But Indiana used to be Eastern Standard all year. Then a couple of years ago, they went on to daylight. Evidently, Arizona is still standard year-round. Hawaii is standard year-round. I don't know about Alaska because you can't really control the sun up there. They said 13 states have passed this bill waiting for the Congress to release them to not have to switch their time clocks at twice a year.
I do remember something about the Congress was considering release or loosening the restrictions on it, allowing states to decide one way or the other. I don't know. I'm just not clear on the details, right? So I was waiting to hear more information. So
maybe there's something in the original World War I law that says states who border two time zones have the option to decide which time zone they want to be in. Maybe there's a caveat for those states.
Stanford. No, can you guys hear me?
Yes.
Okay. So the deal is that the way the law is now, you don't have to do daylight savings time, but so you can stay in standard time all year long if you want. What Missouri, they just passed, and some other states have done, is what they want to do is stay on daylight savings time permanently. Current federal law does not allow you to be on daylight savings time, like to opt into daylight savings time all year long for whatever reason. So you can opt out of it completely, but you can't opt in completely. So that's what they need to have change.
That explains it.
Interesting. Okay.
Your government at work.
Hey, I hate to bring the Q&A to a close after our main presentation. A number of people stay around afterwards. So I think there'll probably be more opportunity to just chit chat and throw out some general questions, but that'll be after our main presentation. So unless there's anything pressing that we absolutely need to do, I want to go to our main presenter of the evening. Hearing nothing.
I'd like to I'd like to say traditionally we shut off at 9 o'clock, but we don't have to. If it goes beyond, that's fine.
All righty. Okay. Thank you, Stan. Our main presenter this evening is Stephen Borrelli. He's the principal software engineer for MasterCard. For those of you who aren't aware of it, MasterCard, yep, the one that does the credit card, their worldwide network operations center is right in St. Charles. So although New York is their financial center, the techie people, they're run out of here. So he develops infrastructure automation software there. And prior to being at MasterCard, Stephen founded Aster.is, and he's been a core contributor to the open source Mantle.io project. If I remember right, I think Stephen was originally a mechanical engineer by university training, and then found himself drawn into the world of Unix. So we've been very fortunate. We've had him as a speaker, I think most recently in 2016, I think. With that, I think I'll turn it over to Stephen and go.
Hello, everybody. It's nice to talk to everybody again. I think I've been involved. I think I came to meetings like many years ago when I was just starting to, like when I first came to St. Louis, and I think you were meeting over by Sunnin. How many years ago was that? So, and before I start, how many folks here have used like Docker or Kubernetes? So just so I get a...
I think I've tried and failed.
Okay.
I've done some, but certainly wouldn't call myself an expert.
Perfect. That's good to know. Tell me if you could see my screen. I should be presenting right now.
Yes, we can.
All right. And presenting with me, we have a guest. I invited him. It's Andrew Rinhard. He's the CTO for Talos Systems. Andrew, I don't know if you're online.
Yeah, I'm here.
Oh, cool. Yeah, so if you don't know Talos, they're doing fantastic work. This is how I actually got involved with, reaching out to Andrew. They're actually writing their own operating system that is like purpose built for Kubernetes from the start. So it has like a really bunch of cool features to it. So the context of this talk is this is being presented to KubeCon next month. And we had approached the Linux user group because we're like, hey, we'd like to practice this talk before we actually present it to KubeCon. And then KubeCon's like, well, it's all virtual and we have to record everything in advance. So we actually had to record this talk. We ended up like last week crunching it to get the recording in. So, which was pretty funny, but we're very excited about this talk, and there's some like really cool stuff that we're hoping to do. And, me personally, I've been using Unix for a long time. The first Unix systems I worked with were Sun systems back in college in the 90s, and then AX, the first kind of RS-6000 systems back then. And then, I personally owned the Next computer. That was, very influential for me, like the progenitor of Mac OS and iOS. So I was a Next user, and that really influenced me because I definitely, from that point in my career, I was more of a Next partisan than like a Sun partisan. Yeah. And after that, I went to AX and then started doing Linux work. So that's kind of my background of Unix. And just thinking about, and most recently I've been doing like a lot of Docker and Kubernetes related stuff. Maybe Andrew, you could talk about your background a little bit.
Sorry, I had to find the mute button. Yeah, my background, oops, sorry about that. Give me 1 second. My background is I didn't actually study computer science. I studied physics, but I've always had a passion for Linux. I don't have the great origin story that you have, Stephen. I got introduced to Linux just by hacking on Android phones. I was really interested in rooting them, writing bash scripts to overclock the CPU and set new scheduling algorithms for Linux and stuff like that. And over time, I started to learn about containers, and I put the two together and started to create a container-based Linux distribution, which we call Talos. And now I am the founder and CTO of Talos Systems, the company.
All right, so yeah, so the rest of this talk, we're going to talk about a lot of really interesting things. We're going to go into Unix history a little bit, but just so you know that the idea about Kubernetes is kind of like this distributed system that runs containers. So if you've ever worked in like high performance computing or any clustered system, just think about like the context here is that we want to have a bunch of servers that we can manage centrally. It's kind of really the goal that we're going for here. And how can we do that and like reimagine the way things work? So that being said, I'll get into the talk. And I tried to get the numbers on the slides, but I don't think they're going to work really well. So just if you have any questions at all, just ask, because I know we have varying levels of experience with some of this technology. So we'll be happy to answer any questions you have or give you more background.
This is Stan. I do see a number 2 on that slide that's being presented now at the very bottom.
Perfect. Thank you. Yeah, the first slide is kind of the KubeCon welcome slide. So, but I like this one better. Imagine COSI comes from like an alternative timeline. You're talking about the Unix history. We'll talk about it a little bit, but imagine that Unix evolved in a slightly different way, and then we'll bring this technology into our current timeline here. So, so I first wanted to talk about what is COSI, and I say it COSI like in Italian with a little accent on the end, which is just so you know it. So Andrew and I say it differently, but I always say COSI, which is like, you know, if you, but it's really the common operating system interface. And the goal here is kind of to present a common API for managing and configuring Linux. It's not something we've really had on the Unix side or the Linux side. We've had things like POSIX for the system interfaces, and you know, we've had configuration management systems, and COSI is not that. COSI doesn't wrap anything else, and you'll see when we talk about it what we mean by that. So this is really the goal. We want to have a common set of ways of configuring systems. Let me see if my, hold on here. For some reason, my thing is not advancing my slide. So excuse me 1 second. It's very odd. While we're doing this, does anybody, well, let me figure this out for a second. Does anybody have any, that's still fine. I don't know what's going on.
Yeah, I'm happy to answer any questions that might help. Sort of.
What are you, this is Stan, what are you using to present the slide?
It's Keynote.
Keynote, okay.
Yeah,
Don't know anything about Keynote.
Yeah, for some reason my, there we go. For some reason it was stuck. Oh, okay, so I apologize for that. My keyboard was not working for anything. It's really a reimagination of operating systems. We've kind of taken the use case that we have, which is this configuration of systems, and rethought about like what kind of operating system would be good for that. And the reason Andrew's here is because he's been working on Talos for I think about 5 years now, right? And what attracted me to Talos was that everything is API driven. So it doesn't even have systemd on it. You boot it up, it boots in memory, and everything you could do on it is via an API. So it's a really different way of thinking about Unix systems. And I was coming from, I moved out of the Kubernetes land and I moved into systems management and like working with Chef for a little bit over the summer, thanks to some corporate reorganizations. And I found out that I hadn't used those kind of systems for years, and I was very frustrated, you know, like how do you configure Linux systems and some of the issues we saw. So that's kind of the idea with COSI. And the thing is, when we talk about this, like if you've heard about Kubernetes, you know that it runs on Linux, and there's a lot of things around Kubernetes. And I have some acronyms here that you may not have heard. Cluster API is a way of configuring. It's like a standard API for configuring and deploying Kubernetes out to systems. Those two things there called CSI and CNI, those are storage and network interfaces. So if you've never used Kubernetes before, what happens is something like a job asks for storage or to ask for a certain networking thing. And then these standards are kind of how Linux provisions those to the pod, the unit of work, like your container. So it's kind of like there's an API and then there's a reference implementation in the backend. So think about that. You know, the use case that Kubernetes wants to have is that when you bring up, like, say, a database and you want to run it in Kubernetes and you want to attach storage to it, you ask Kubernetes to say, give me 100 gigs of disk. And then Kubernetes will talk to the system and figure out how to provision that using the CSI standard. So if you've never seen it, it kind of abstracts out what's happening on the operating system. And if you've been using Unix your whole life. This may be something different for you because you're used to like maybe going down and creating LVs on the system itself and creating file systems and doing things like that. This is kind of an automated way of doing that. But there's one thing is that
question here: the slide deck, is that going to be available, or do people have to write furiously?
Yeah, it's actually, I'll post a link of where it's available. The PDF is actually on the KubeCon talk, and I could share it with you here too. So it's
fantastic.
Yeah, yeah, of course. Yeah, so one of the things that we're finding is that Kubernetes and Linux, they differ not only in the technologies they use, but also philosophically. And this causes a lot of problems in the interface between, Kubernetes, which is really this almost distributed operating system that runs across nodes and does like a lot of abstractions. And then what we find is, Linux tends to be slightly lower level and it's focused on a single system. And we'll talk about some things about Unix history, about the philosophy of Linux, how it might differ from Kubernetes. So this is actually a source of problems. And like a lot of the, I mentioned CSI and CNI and some other things like that, but like provisioning from Kubernetes, it doesn't really handle provisioning of the nodes and configuring them. So that's kind of out of band for Kubernetes, but also anything, every time it has to reach down in the node and ask for work to be done, there's not like, it's kind of built into Kubernetes right now. And then it's different than like, say, so you have two different tools, like, and Andrew, maybe, I don't want to speak of you, but like he writes software that provisions Kubernetes to the cluster, and then Kubernetes also, so that talks to the node and configures it. And then once Kubernetes comes, it also does some redundant work where it's also talking and configuring the node for certain things. So we have a duplication of, functionality in two different tools. So yeah, this causes, problems. So we're going to talk about desired features here. And I thought the talk on shell was really good because I actually learned quite a bit. So I appreciated that. But one of the things we're talking about here with COSI is actually we don't want to have a shell or SSH. So I think this is probably one of the first things. One of the reasons I wanted to talk to the Unix group was to actually talk about this, is that we want everything to be completely API driven. And we actually don't want users on the system itself. We want people to think about these systems as almost like appliances that are completely manageable remotely. Another thing is that we want to model all the configuration settings on a Unix system via an API. So this means if you're used to, the old joke in the old, since we'll talk about Unix history, was like, understanding a sendmail file, how every single Unix utility tends to have a different configuration file and different ways of managing it. We really want to have a standardized way of how do you set Unix configuration and a standard way of like setting and getting those on a system. So think about like the RPCs and how many folks have used AX here, by the way? Any AX lovers here? Because I think AX is the best Unix, me personally. I'm gonna.
I use it. I can't
like
say I
AX.
love it or use
Who are
it
the
a
AX
lot.
people here? Because I love that's my favorite Unix. And what I liked about AX was it actually had some really cool things about it. But if you have used an AX system, almost everything in the system is modeled like via the ODM. And now I haven't used AX in many years now, but they had the verbs like make, get, like where you can make LVs, you could change LVs, you could delete LVs. So they had like for almost everything in the operating system, you could apply verbs to it. So now we're thinking about exposing this via an API.
Question, that AIX is phonetically Alpha India X-ray?
Yeah.
Correct.
Okay. I'd like to point out before you go further on that SSH has the capability of not using a shell.
Yes.
Glad you know that.
Yeah. Actually, we'll talk about that a little bit because SSH is really an interesting case about Unix history because it actually implements like terminal emulation in it. Like if you ask for PTY and there's actually, you could ask for columns. If you look at the SSH RFC, you could actually look inside of it and see, hey, it's going to ask for terminal, rows and columns for the display that comes back. So it's really interesting. Now, I have two terms here for the next thing, similar pattern to Kubernetes controllers and CRDs. If you've never used Kubernetes before, this might feel like these are terms that you probably have never heard of before. So I'll just say a Kubernetes controller is basically just an application that runs all the time, and it tries to get something to a desired state. So that's basically it. on a Linux terminal, you might think of something like a systemd, where you give it like a unit or something like that, or a service file, and they'll try to get it running. That's basically what a Kubernetes controller is. And the CRD is called a custom resource definition. And what this basically means is you can extend the platform itself. So imagine if Unix had like a standard way of, like, in Unix, every utility has a different configuration file format. Imagine if there was just one that was like JSON, and you just said, whenever I want to configure this, I could just add it to Unix itself and say, I want to configure name service resolution, and these are the fields that I want to configure. So it's a standard way of extending the platform and having like a standard configuration file. And then finally, something we'd like to have is events. And one thing here is like, there is like low-level eventing in Linux, but it's, and I don't know if Andrew wants to talk about this, but it's kind of not a great interface to deal with. And yeah, I think it's mostly used on the desktop side, and we don't really use it in server software.
Yeah, I don't have much to add other than it does exist, things like dbus and, all that, but they just haven't been utilized for whatever reasons. The interface is clumsy, and for whatever the other reasons, people may not have new ways of kind of interfacing between different programs, regardless of language, have emerged, such as gRPC, which is, as you guys will see shortly, the technology that we chose. But yeah, that's all I have to add to that.
Thank you, Andrew.
Quick question, define that term CRD again.
It is a custom resource definition.
Great, thank you.
So, yeah, so Kubernetes has like some built-in things, like if so I'm just gonna say here, like Kubernetes has this idea of a pod, right? So you say, they have things like ingress controllers and some other things like that, like their core primitives. And when you apply a CRD to a Kubernetes system, it could be something that you built that makes it look like Kubernetes, like it's just Kubernetes itself. I know that's kind of, it's like an extension mechanism that's very flexible.
Okay.
Yeah. It's a very powerful feature of the platform because it makes you, allows you to build higher level platforms on top of it. I could talk about that in a future talk because I'm actually moving to a company that writes Kubernetes controllers for infrastructure. So maybe that's the next time I come back in a few months, we can talk about the Kubernetes CRD model and how it helps you write API infrastructure.
Great, thanks.
So just for the rest of the talk, we're going to talk a little bit about Unix history. Going to talk about modern container operating systems. If you're not familiar with things, you might have heard of like CoreOS. Hopefully after this, you'll be super interested in Talos because I think it's an awesome operating system. The bottle rocket and flat car. And then we're going to talk about COSI. And then I don't know if we'll be able to do a demo, Andrew, or not, but this was on
have it ready to go. So if we do have the time, I can show something.
Cool. So we're going to go back in time. I love, because if you know me, I love Unix history. All these slides for the next few are from the 1982 Bell Labs film. I don't know if you've ever seen it on the internet, but it's like 18 minutes long, and it has like some of the key figures in the history of Unix, and obviously great graphics. So I really love it. And so the first thing we really want to talk about Unix history, to understand COSI, I feel like we need to understand Unix history and the philosophy a little bit. And the first thing is one, that Unix is really the planet's dominant operating system at this time. Whether it's phones or routers and large compute clusters or even development laptops, Unix is pretty much everywhere. But going back to the history of Unix, it really was a reaction to Multics. And I think on the mailing list, you had that was it last month where you had a point to the podcast where Brian Kernighan was talking about the history of Unix. I thought that was really timely. But really the thing to understand is that Multics was kind of a complex system that was floundering in its development. And the developers who made Unix, they really were reacting to that, and they wanted the radically simple system. And what they really wanted, this is a quote from Dennis Ritchie, he said he wanted, a system that programmers could share and work together with and collaborate. That was something really important to them.
This is where I have to interject that when I saw this presentation 40 years ago, the quote was, using IBM's TSO is like kicking a dead whale along a beach.
I wish I had that for the presentation to keep going. That's great.
and thus the Unix shell was invented.
Yeah, yeah, it's great. Yeah, so Unix, and something to understand is that Unix is a multi-user time-sharing system. I think sometimes we forget that, but the origins of Unix were you had a bunch of people hooking up serial terminals to this shared system, and they were working on a shared system. So file systems were shared, CPU was shared, memory was shared. And this is why I thought the tutorial before was really wonderful, because we talked about shells, right? And programming them, and there were shell built-ins, and that there were, shell things that called out to the system. So it was really getting into like the core of what Unix is. And the way you compose the work is like you take this shell and you use it to, combine commands, very simple commands, which is a Unix philosophy. We take, so that's really the core of Unix. Even to this day, these basic concepts really hold true. And we had talked about secure shell, which is another great question. This is why this meeting's actually, I'm enjoying it very much, is that you go into so we went from serial terminals, then we went to remote shell, which was RSH, right? Which was serial terminals over the internet. And now we have secure shell, which is basically encrypted serial terminals over the internet. So if you run secure shell and you don't allocate a PTY, but you send some like SSH characters, you can actually cancel your session. So it's just like, there's weird things there, but an SSH is basically emulating a serial terminal to this day. This is the main way, like, if you use some, Kubernetes distributions that use SSH, they're basically, we're just recreating the infrastructure of the 60s and 70s to this day. Another cool thing is that Unix, and if there's I think it's a 74 or 76 paper by Ken Thompson where he talks about this, about the pipe and the Unix philosophy about unstructured text. Where a huge thing about Unix is that we process basically raw text, and in order to process it, we pass it through a number of filters, which we call pipes. And what I have down here at the bottom is from that, I think the example that they have of a spell checker, where they actually do all these different functions on a stream of text in order to, spell check the document. So I thought that was interesting. One thing we want to talk about here, though, is that this is not necessarily a workflow that we do today. Like, you wouldn't like necessarily do spell checking this way. We usually do spell checking on the fly when we're writing a document, and now we have it in line. So these are again, this is a core, this unstructured text and this kind of linear flow is kind of a core concept of Unix that may not fit today. Does anybody have any questions so far? Or I hope they're enjoying the history lesson. I tried to color code it to the video, so.
Love it. It's great.
Yeah, I love old history. So this is a total sidebar since this is not QCon, but like I would like read papers from like the 50s and 60s all the time, like the Multics papers. I like all this old stuff, so I love it.
Yeah, why did we stop using these fonts? They're awesome.
Keep going. This is good discussion philosophy. My only question so far is, why didn't you call it container operating system interface?
Because we actually want. Oh,
sorry. Sorry, I was just going to jump in. It actually did start out as container operating system interface, but we didn't want it to be just limited to container operating systems. We wanted this to be something that can live beyond this whole container rush that the industry is going through right now.
Good explanation. Thank you.
Yeah,
sorry, Stephen.
No, that's great. Another thing we're looking at is like micro VMs, like if you use Firecracker or something like that, right? Can you, that are not necessarily containers. So there's a lot of things we could do. Oh, by the way, I can't necessarily pull up the chat. So if there's anything I need to know, I saw there's like 4 messages there. So if there's any questions or anything, just let me know and I'll answer them.
I'll keep an eye on them for you, Stephen. If I see a question, I'll interrupt.
All right, so let's talk about fragmentation. I think one of the issues, the other thing I want to highlight about Unix is almost from the very start, because of the way Unix had to be licensed out because AT&T was a monopoly at the time. We've seen a lot of fragmentation in Unix over the years. For the first couple decades, it was between commercial operating systems, and it was between the BSD folks and the AT&T folks for the longest time, who's on what side. And then in 1991, so we're coming upon 30 years, Linux came out. And Linux pretty much wiped out a lot of the commercial Unices, but we have a lot of fragmentation on the Linux side. I mean, that's kind of where we were pretty much until 2013, that we have a lot of Linux distributions that are all like semi-incompatible with each other. So let's get into the container age. In 2013, it's probably when Docker started coming out. I was one of the founders of the Docker meetup here in St. Louis about 2014. Well, that's when I started getting into this stuff. And containers really changed the way we think about the developer experience on Unix. And I think, you know, looking back, and I don't have this in our KubeCon presentation, but I really think that Docker is going to be one of the most fundamental changes to Unix in the entire history of the platform, because it took over some functions that had been there, you know, C groups and namespaces, and made it really easy to have these packaged applications that didn't depend on like the shared file system underneath. So it really started unleashing a lot of different changes into Unix itself, which I think COSI is like one of the natural progression points because of this. You know, we started having a lot of containerized workflows, and then to do those, Kubernetes eventually ended up like wiping out most of the competition. I started on Mesos myself, Apache Mesos. There were a lot of other cluster schedulers that did not make it or don't have any kind of mind share today. And as part of that too, we got the rise of container operating systems, which I think is, if you've never seen one, like CoreOS I have here, but basically a container operating system really has everything stripped from it except what you need to run containers. And they're usually pretty low level. A lot of times they're read-only, and they almost run like a device operating system where you have it installed on two partitions, like an A partition and a B partition, and you upgrade one and then boot off of it. So they tend to be a little different than traditional Linux distributions. So that's kind of where we've been going recently. They changed a lot of assumptions. I think they're a lot different than traditional Unix systems, but in a lot of ways they're recreating the issues that we've seen in terms of like fragmentation with traditional Unixes. And I talked about 4 of them here. So there's, if you've never heard of any of these, Flatcar is a descendant of CoreOS after they got bought by Red Hat. There's Talos Linux, which comes from Andrew's company over here. There's Bottle Rocket OS, which comes from Amazon, and then K3 OS, which is from the Rancher folks. And what I wanted to talk about here is that they're different in many ways. Like we don't have a standard API. Some of them use systemd, some of them don't. How you configure it, like this user data is like when you boot a cloud node, you send it data, and we don't really have a standard way of doing that. So there's just like a lot of things there that are not the same. So there's been a lot of progress, but one of the things I'm concerned about personally is that as an industry, we're not really coalescing around any kind of standard. So that's one of the ideas for COSI. So we run the risk of repeating Unix history and having multiple incompatible operating systems, but we've seen with Kubernetes ecosystem that we could define common standards that allow innovations. And that was the whole CRD patterns, right? Like that you could just have a common way of extending the platform without having to invent your own infrastructure. So with that, we're going to get into COSI. So this is the state of it, and it's in heavy development right now. And a lot of things are changing, but I was going to talk about what it involves. And this is going to be, if you've never seen a lot of these, so this is kind of aimed at an audience that is a little more Kubernetes aware and may have heard of some of these things. So if there's a term you don't understand, please don't hesitate to ask about it, because I'll try to explain everything, but it does make some assumptions. So the first thing is that COSI has a modeled configuration. And what that means is that, and this is in YAML, but we don't really care what it is, but what you can see here is that we have things like everything that you would configure in a Linux system for a container operating system, right? Our goal is not a general purpose Linux system because there's too much to configure there and we don't want to get into that. What we want is an operating system that's almost like an appliance that could run the Kubernetes infrastructure, some plugins that Kubernetes needs, and that's about it. So the first thing is that it's a modeled configuration. This means that everything, has a specification that's very well defined, that's typed, that can be implemented in any language. Basically, we're using something called protocol buffers to define all these things. So that means that you could just run a protocol buffer compiler if you want to, like, say, write a client in Python or write a client in Go. You could just generate, based on these specs, you could generate your client. So we want to have developers be able to configure these systems in any language. The second thing is that The next thing is we define common RPC definitions. So if you remember when I made that comment about AX, this is kind of something similar. We want to say, I want to get the settings for this. I want to set them. I want to delete the settings for this. We want to have a common set of definitions here so that you don't have custom commands. The third thing is we want to have a plugin standard.
Term RPC?
So, yes, remote procedure call.
Right.
Yeah, because we are not allowing SSH on the system, all your communication is going to be via a single API endpoint. And so then we could control things like RBAC and authentication. Like if you look at Secure Shell today, it's out of channel of the rest of the system security, right? Like it's like if you have a web, like it doesn't mesh with like web security. If you have there, you know, like you have your one infrastructure for managing web endpoints, and then you have another infrastructure for managing Secure Shell and its keys and everything else. So this is just an API endpoint on the system. So we expect this to be very secure. You know, just, and then and then there's a plugin standard. So one of the ideas here is that these plugins are just little Unix programs, but we want to have a standard communication plugin so that anybody can write whatever backend that they want to configure it. We want it to be as flexible as possible so that whatever tool you want to write to configure something on the system, you just write it as long as it matches the interface, it's good to go and it'll integrate with everything else. And then we have a reference implementation that Andrew's been writing in a language called Rust. Are folks here have heard of Rust or?
There's been some discussion.
Okay.
And a couple presentations.
Okay, cool.
So actually, I'm curious, like, why did you choose Rust over, say, Golang or C or something else?
Yeah, so as we'll see shortly here, COSI really is split across two main concepts, the engine and the runtime. The engine, we're a little hesitant to say this out loud, but in some ways it can compete with systemd. And we felt that Rust's memory guarantees and performance benefits would apply very well to, say, a PID1. In Talos itself today, we do write our own PID1, and it is written in Go. But we're making the migration here since the COSI engine is going to be very, very minimal. All it's going to be responsible for really is ensuring that plugins are running at any given time and orchestrating the communication between the plugin and what we're calling the COSI runtime. The runtime is actually written in Go, but we did choose Rust because of the specific reasons of, or the vision at least around the engine, that it could potentially be a PID1 one day. And again, the memory guarantees and the performance are very appealing in that context.
Cool, thanks.
Cool. I'll move on to the next slide. So models define the operating system as protobuf messages. So what I wanted to show with this slide is basically we take settings that are in the Linux kernel itself, and those actually are composed of messages that are typed. So the idea here is that as long as you adhere to this message format, you could write your client or your server in whatever language you want. What we want COSI to be is a standard set of specifications that configure a Unix-like operating system. So we want to get away from having like a custom configuration file that has to be parsed in your code to something where like, this is what needs to be set, and this is how you send it across the wire.
So, sorry, I'm not familiar with the term protobuf. Is that like pseudocode?
Protobuf is, maybe Andrew could explain this better. It's a communication protocol to encoding data across the wire.
Yep, that's how I would summarize it, is exactly that. I believe it came out of Google. It's basically a very efficient way to send data on the wire, essentially. It could be related. It's equivalent to not equivalent, but it's in the same realm as JSON, for example. But just protobuf is much more efficient.
Thank you. Good explanation.
Yeah, so here what we want to say is that we want to model what's the actual configuration and be as close to the kernel API as possible, so that we want the clients like, so when you have a protobuf like this and you see this message, there's lots of tooling that then says this could create, you could then write the code and say, hey, like have Python actually set these things and then, you know, request them over the wire. Like Kubernetes, there's common operations, you know, list, get, create, update, destroy. Actually, something we're looking at right now is that there's a Google proposal for declarative infrastructure, like API standards for this. So I think that will influence this a little bit. But what we want to say here is that, like, this is what you have to implement if you're going to do COSI, right? So if you're used to Unix up to now, we're very tool centric, like it's systemd versus an OpenRC, or it's IAP tables versus, you know, netfilter or something like that. And how you invoke the tool depends on how the tool is written. We kind of want to decouple that and say, as long as you have the right settings and you talk to the API and say, okay, create it, it'll be done on the back end and you don't really care about how it's done. We'll talk about gRPC here just a little bit. If you don't know about it, it's protobuffs over the wire. So everything is bidirectional. So this means that this actually, if you know, I don't want to get too far into gRPC, but it's on the HTTP2 protocol, and it could do streaming between consumers. Like it's kind of a bidirectional pipe. So you could be sending data and then getting streaming data back at the same time. And another thing is that one of the goals here is that the COSI is different than configuration management, is that we don't want to wrap other Linux commands. The goal of the plugins is to be as close to the kernel as possible. You know, either calling the kernel directly or calling APIs that are very low level to the kernel. So we don't want to be execing out to another command and then parsing the output. I don't even think we want to use the pseudo file systems like proc or things like that if we can, in preference to actually being very low level. Plugins manipulate state. They talk to the COSI engine via Unix socket, and they take inputs and outputs, right? So it's kind of like standard in and standard out, but it's more structured. And they will talk directly to the kernel to create files, to configure. Andrew could probably talk about this, but they talk directly to the Netlink API to actually configure the network and do other things like that. So this is different, right? Like if you've been using Unix for a while, you're probably used to like writing a shell script or, you know, using a chef or an Ansible to do things for you. These plugins are very low level and they don't wrap anything. They just will go and set the thing very, you know, themselves. One of the things that was really cool about the implementation that Andrew has been designing is that every plugin is like a Unix utility, but it runs continuously. So, and the COSI engine kind of, you know, or anything could control its life cycle, but when you bring one of these plugins up, it registers itself with the engine and says, these are all the things I can configure. And then it just runs continuously and waits for being told what it needs to configure. So this is kind of like how a Kubernetes controller works. If if you're looking at how the Kubernetes model is very similar to this, and it was inspired by it, or we inspired by Kubernetes. Anybody have any questions about this slide?
This kind of expands to something else, but rather than running continuously, is there plans or ideas to turn that into a serverless application so that the plugins aren't running up CPU time, but just come alive when they're needed?
Yeah, that could definitely be. That's a good idea because the engine controls the life cycle for them. I think Andrew.
I mean, it certainly could be possible. I think what we would be interested in first is looking at what is the practical hit CPU wise and RAM usage wise of having these things run continuously. And if it's something that is negligible, then I think we would prefer to run them like controllers because you'd get a bit of a more, they can react. You can set up, like Stephen was saying, you can have bidirectional watches. These things can actually get events in real time. And it gets a little more complex than just invoking a single program at a given time. Programs may be subscribing to, Stephen has two examples of plugins here, one setting up a file or something like that, another one doing some networking configuration. It could be that the bottom plugin here actually depends on some output from the file plugin, but they are kind of only aware of their inputs and outputs. The runtime does the orchestration on a very opaque abstraction in a very opaque way. So it gets complex very, very quick when you start talking about building this dependency graph between all these different plugins and when we should invoke what and what events would trigger that and so on and so forth.
I've been following this pretty much along till this point where I hit the word controller. Is that like a socket?
Stephen, I'm happy to handle this, or I know this is still your portion.
Go ahead. No, go ahead.
A controller really is, how do I say this? The way that we've kind of traditionally done configuration of Linux, it's very imperative, right? I'm going to write this bash script that executes this SSH command, and then it cats out this file into an appropriate place, and I'm setting variables and so on and so forth. In the controller world, or in the Kubernetes world, the idea is that you declare what you want your state to be. And these controllers continuously try to take the state of the world and make it align with the desired state that is declaratively defined via some configuration file. In this case, these are just protobuf definitions. Could be represented as YAML, TOML, JSON, whatever. As long as we can serialize and deserialize and send them over the wire, these controllers essentially sit there and watch for these definitions that you want. And instead of you as the end user having to go in and actually open up a file, find the line that you want to edit, and doing all of these things, the controller just looks at, hey, this person wants a name server, and I know exactly what I need to do that. And it sort of abstracts away the implementation details. I don't know if anyone is on Twitter and has seen it recently, but I believe Dave Anderson recently shared his experience in how to configure DNS. And there's this crazy graph, right? Systemd has introduced its own thing. Network Manager has introduced its own thing. And those all can live fine and well underneath the COSI project. But you as the end user shouldn't have to worry about the 5 different ways of doing DNS. You should just be able to say, here's what I want my DNS to look like. And then a controller goes and in behind the scenes makes that a reality for you. Does that make sense?
I think so. Kind of like an object module of some kind that says, this is inputs I want, and this is what I'm going to give you. Output.
I think that's a fair, yeah, I think that's a fair comparison.
Thank you.
Yep.
Move along.
Yeah, let me get to, so another cool thing is, and this is actually another cool thing. So I think one thing is if you're kind of watching what's happening at the leading edge of Linux, there's a lot of really interesting things happening. And one of them is this thing called eBPF. I don't know if you've heard about it, but it's a way of kind of embedding programs into the kernel that could do all kinds of things. There's this idea of, in COSI, how do we get events out of the kernel? And we have this thing of a generator. So what happens is the generator will deploy a BPF probe. And this is kind of out of the scope of this talk. This could almost be, if someone's interested, another whole talk in itself, because BPF is like really cool technology. And a lot of people are talking about it can completely change the way Linux runs itself. So what happens is you compile these programs and they're kind of like just-in-time compiled. And then you can have a probe that's put into the kernel, and then it can send out kernel events. And then what the generator does, it sends those out as structured COSI events. So we may be able to demo this. I assume this is part of our demo, but just seeing like what this would look like in real life. So it's kind of cool.
I do have this queued up for the demo. So
woo! Yeah, this is yeah. And then I think at this point, usually I transition it over to Andrew.
Yeah, sorry, I'm just trying to find a USB stick so I could show the demo. So yeah, the engine and the runtime, we briefly got into what this is, and I just want to give a brief overview again real quick. The engine, as we're basically calling it today, is a reference implementation. It very well could change very quickly. It's still a very young project, and we have some really great minds that are coming on and sharing a lot of differing opinions, and things may change, but the general idea is that the engine right now is basically a long-living server, and it listens on a gRPC endpoint. You can almost imagine this for those that are familiar with REST. This is just some server that exposes an API gRPC is just an implementation detail. You can imagine it as a REST server if you really wanted to. And its whole goal is to basically do process management. It is going to start plugins and it's going to tell plugins, here's how you connect to the runtime. The runtime is basically an internal API that plugins use. As like we were talking about earlier, they can set up bidirectional communication. They can subscribe to events. They can say that here's an output that I'm going to produce and I exclusively own it. Or this can also be shared by another plugin. It can also say, I want to get all inputs from this API and I want to be notified when they're updated and created, even so far as saying as blocking the deletion of those things, because I need to do some cleanup work before those things can be deleted. And so the engine and the runtime sort of do process management and some kind of internal API management. And so, Stephen, I think we can go to the next slide. And happy to answer any questions if that was a little too quick. I'm just trying to be conscious of the time here. I know you guys said we could go over, but I don't know how far over. All right, well, feel free to interrupt me.
You can go quite a ways over. It's only 8:16. We can go for another hour easily, no problem.
Oh, okay, great. Stan, do you mind muting? Because I think that the noise is back. Thank you. So if you guys haven't been able to tell so far, really what we're proposing here is a different way of thinking about the Unix philosophy, and sort of as Stephen has been putting it, and I really love, is thinking about it in this alternative reality. What if we had to rethink Unix in this world where we had distributed systems and we had containers, this whole new way of thinking about Linux? We've set up something here on the left, which is sort of the more traditional way of thinking about Unix. And what we want to, and I want to be very clear about this, is we're not necessarily trying to replace Unix. We actually look at COSI as an evolution of Unix. And so on the left here, we have sort of the traditional way of thinking about it and the way that we're thinking about it in this, in the context of COSI. And I should clarify again that COSI really isn't designed for, say, desktop Linux. This isn't something that you're going to go and develop your application on. This is server-side Linux built for fault-tolerant, highly distributed systems. So just keep that in mind as we go through this. So instead of a single shared system, we are more interested in isolated workloads. We're more interested in having multi-tenant solution built on top of this Linux distribution. The shell, this is going to be a, we had a whole nice presentation on the shell earlier, but actually in COSI, we actually want to throw out the shell. And we do this because the shell is really designed for human interaction, whereas an API is designed for machine interaction. And going back to the idea of plugins, these are machine-driven things, right? These are machine, very living and breathing programs that react to events. And again, they will take your submission as a user, but you aren't the one that's actually invoking it. You're just telling this thing how you want its output to look like. And so an API makes more sense in this context where two programs can speak to each other over a structured data interchange format. We just know this from practice. That's why we've invented JSON. That's why we've invented a lot of the things that we've had, because they just work better for machine communication. Building on that, we've also thrown out the idea of an interactive user. The whole user space in the world of COSI is not necessarily a human hopping on literally over SSH and doing something on this machine. You are submitting what you want your world to look like, and controllers will handle that instead. And so there's a very clear separation. The boundary is at the machine, and you are a remote user. You are not able to actually get on the machine in the more traditional sense. So we take out all of that interactivity and we replace it with the concept of a controller. Another idea behind this is that the whole Unix philosophy has really been driven by this idea of the pipe. But there's a reason why we have awk, sed, and grep. These are the three most utilized utilities in the Unix world. And that's because the output of all of these random programs, they have never been structured from the beginning because we didn't have the idea of structured. You know, JSON didn't come out, I think, believe until the 90s. And so it's really just made for a world that is full of inconsistencies. And that just doesn't work well, again, for machine-driven things instead of human interaction. Human interaction, that's just fine. I can kind of analyze things real quick, and I can figure out I want to look at field 3 and I want to cut out this character. But for machines, it gets very complex very, very quickly. And so we're basically swapping out this free form data exchange into a more structured exchange of a text stream. And instead of pipes and utilities, what we're more focused on is, again, machine-driven ideas, which are these plugins, which kind of live longer than just invoking a utility as a one-time thing. Does that make sense?
Yeah.
Yes, you're creating drones and you line them up and turn them loose.
That's right. We're building Skynet. I think, Stephen, I am ready for the demo if you guys care to see that.
Yeah, let me stop sharing and then I'll.
All right, can you guys see my screen?
Yes, we see it, the terminal.
Okay, great.
The font, however, is a little small. If you could boost up the font size, I'd appreciate it.
How's that?
Maybe a little bigger.
I'm on a wide screen. I think that's why it's.
That's nice.
That work? Okay. So I didn't want to get you guys through the whole build process of COSI. It doesn't take too long, but I did start it in the background here. And what we're looking at here is what you can imagine as PID1. You can imagine this would be the console output of your Linux operating system. And we can see that the engine is saying, I'm listening on this local Unix socket. I have loaded the runtime, and I have loaded these generators and plugins. We have some very early stage generators and plugins. I have an ACPI event generator. I'll show you exactly what that means. A disk generator, a mount plugin, and a resolver plugin. I'll step through these if they don't really make sense so far. But you can see the difference between a plugin and a generator. And by the way, anything that's between these two that's sort of prefixed here with the colon after it. This is the standard output of the plugins. So the engine is actually setting up the standard output of the plugins to be its own standard output so that all logging basically goes to one centralized place. But you can see very quickly that the difference between plugins and generators, the generators are doing, they're loading what are called K probes. And what this is I'm literally hooking into a very specific function in the Linux kernel. And every time that is invoked, my program will also be invoked. I have access to the arguments that are being passed into the Linux function. This is what eBPF is. And so we get a very low level access into what the kernel thinks its current state is. This is a lot different than, say, using the netlink API or parsing /proc. We are actually tapping directly into when the kernel updates its own state, we are also able to capture that event with the exact same args that the kernel is getting, and we can massage that into however format we want that to look like. And so these generators are loading these eBPF probes, and they're basically telling you which function, literally these are the names of the functions in the Linux kernel that we are tapping directly into. I want to make sure that that's clear to everyone before I move on. Is there any questions?
Is this the matrix?
We're getting there. We're yeah, maybe another 50 years we'll get there. All right, so I've also started what's called the runtime. The runtime is another binary. It's a specialized binary that offers basically orchestration among generators and plugins, essentially. It sets up watches and bidirectional communication, sets up registration and all these different things. It's really just an orchestration tool. Actually, one of the things I really like in that I have discovered or learned in digging into COSI is the originators of Unix really tried to illustrate that it's not necessarily the power of each individual program that makes up a very powerful system, but really what it comes down to is the relationship between all of those and all of the different combinatorics that you can do to really do very, very useful things. You can imagine the OS runtime as being a way to manage that relationship between two different programs. All right, so let me just get to the fun stuff real quick. There is a CLI here. And so I'm going to actually execute, real quick, let me show you guys what this looks like. So you can imagine this file as almost like your etc fstab. Well, let me take that back. You can imagine this particular entry right here, this mount definition, as an entry in etc fstab. And in YAML, you can actually have multiple quote unquote documents defined in a single file. And if I just had sort of a list of these in this file, you can imagine this whole thing as sort of representing your etc fstab. These are just entries. This says, I want to mount this here. That's all that these simply are. But this is very standardized, right? This is structured. A machine knows how to read this and knows how to parse this. And it is not proprietary to how the etc fstab creators decided to do it. I can actually have options here. It's very, very clear that this is the field where options go. If you've ever had to mess with etc fstab, you always have to look up which field represents options and so on and so forth. I can actually define this in a machine readable way.
And most important of all, it's written in ASCII. It's not buried in that horrible Windows registry.
That's right. And so what we're going to do here, I want to be very clear on this. Right now, you can imagine this top terminal here as being our remote system, and the bottom terminal here as being your local computer. Instead of SSHing in to your remote machine and opening up, vim/etc fstab and messing around with all that and hoping that you got the format right and you got the fields all correct, what we can actually do here is we're actually going to submit this over an API. If I can click, am I there? There we go. And we can see that the mount plugin has received this, and it is going to set up a mount point for us. Right now, this is, it's a detail. It's running in a container, so it's actually not functioning. But the idea here is it's actually going to set up a tempfs at /temp for you, and it's going to be defined by what we have here. I can also delete it if I wanted to. And the idea is that these controllers are going to say, okay, somebody has submitted this to me, and now I need to make sure that this can happen. So the benefits here really are that there's a whole, we've kind of learned in practice that APIs, one, are just better, and two, structured data is better. But three, there's something really important here that Stephen has always been sort of advocating for in COSI, and that is we can actually do validation. We can actually go through and validate what you have submitted to the system. And before actually laying this down and making this a reality, we can say, hey, what if I actually said it's not TMPFS or tempfs? What if I actually just made a typo and I actually omitted the S here? We can actually validate that at the API barrier, if that makes sense. And you wouldn't be having this possibility. I know I've done it before. I've messed up etc fstab and had to boot into a recovery system to get it back to functioning because things just weren't working.
In the translation from the client to the server, how did type become R#type?
This is the Rust specific thing. So this isn't actually the string. I'm actually printing this out using Rust formatting. And so type is a keyword in Rust. And so a way around that, if you wanted to use that as a field within your struct, you just do r_type. And that's a workaround in the Rust world. This is not a string. This is just me printing out literally the Rust data structure, if that makes sense.
Yeah, I hear what you're saying. It's unfortunate that Rust had a keyword named type and you wanted your FS tab entry to have a keyword named type.
Yeah, the only reason it's showing up though is because I decided to print it using Rust's print line macro, and it prints it out in a very Rust centric way. But over here, you can see that from the user standpoint, you're not having to type in r_type. You can address it as type yourself. So this is really, I would ignore this if that makes,
it's wrong and you need to fix it.
Fair enough. All right. So before I move on to generators, is there any questions about plugins? I hope by now I've illustrated that it's really just taking a lot of the things that we've done with configuration management and turning them into APIs that have structure. And that's the very boiled down version of it. All right. Well, let me move on to generators. Let me set the stage just a little bit. Let's see, where do I start? Okay, so at my company, Talos Systems, we've been building a Kubernetes-centric operating system. Well, I don't really like to say it that way. I like to say more a modern operating system with distributed systems in mind. And one of the things that we are constantly doing is we are interested in something in /proc, and we are, we're reading these files, and every single file in Linux, well, not every file, that's an overstatement, but there are inconsistencies on how the different fields under /proc or /sys are delimited. Some are space, some are comma, so on and so forth. May not sound like a big deal, but again, going back to Stephen's point in COSI is that we are not interested necessarily in configuring files. We actually want to go straight to an IOCTL or straight to the Netlink API or whatever API as low level as we possibly can get a syscall, and invoking those rather than trying to read procfs or write some file into some location. In Talos, we are constantly doing this. I can't say constantly because in Talos, we are striving to avoid reading /proc or setting up any files. We are striving to do exactly that. We want to use syscalls, IOCTLs, so on and so forth, and get as close to the kernel as possible. But sometimes that just can't happen. And one of them is understanding our current mount points. Underneath /proc, you can get that. You can read it, and we do parse it. But we do that very often in Talos, and these things can change very, very quickly, especially in a dynamic world such as Kubernetes. And so probing these file systems just didn't feel efficient. So the idea here is that we actually want to be able to tap into when the kernel actually gets an update on when a disk has been added or removed. And this is where the magic happens. You can see here that I've attached a kprobe, a BPF program that says, I want to be notified every time the device_add_disk function is invoked in the Linux kernel. And so what I have here is a USB stick, and I'm going to plug it into my remote machine. And you're going to see here at the top that I didn't do anything. This is an event. I actually have my BPF program basically getting this event from the kernel, and I'm parsing this and massaging it, and I can actually tell you via very structured data what has happened. We added /dev/SDA. Here's the major, here's the first minor, how many minors it has, and the operation was add. Now, if I remove the USB stick, I will also get a delete event. You can imagine that another plugin may depend on these events. For example, what if I need to mount /proc and I need to be notified of when it is mounted so that I can do my job, which may be writing something, say a sysctl underneath /proc/sys/kernel. I can actually know when that operation is safe because I will be able to get instantaneous state updates from when the kernel itself thinks that it's got this mount point, if that makes sense. All right. Another example here, and you're going to see me reach around. I'm going to also set up I set up another BPF program where I can actually get ACPI events. So what you just saw right now is I actually pulled out my AC power supply from my laptop, and just now I plugged it back in. So I'll actually be able to figure out even ACPI events. For anyone that has ever had to deal with the Linux Netlink API to get these events, it's not very, very fun, and it's not structured at all. And in Talos, we are interested in these ACPI events, and this is kind of getting in the weeds a little bit, but in the Kubernetes world, we depend very much on what's called etcd. You can imagine etcd as, well, not imagine, it is a distributed database, and it needs quorum. So it comes in the form of either 1 instance, 3 instances, 5, or 7. Those are the more common configurations, 3 being the most common. And the etcd members need to have quorum before they actually commit data into their database. And so it's actually very imperative that you have, at these different levels of redundancy, you have a different level of tolerance in which you can lose a member. So at 3 members, you can tolerate the loss of 1. At 5 members, you can tolerate the loss of 2. So what if we could actually use these ACPI events to say, okay, I want to be aware of all of my etcd members and actually refuse to shut down if that means that I'm going to lose etcd quorum. Because if you lose etcd quorum, you basically can potentially lose a very large portion of your infrastructure and literally be losing millions of dollars for every minute that it's down. So we can actually use these events and subscribe remotely to the ACPI events on another machine so that we can actually tell if another machine is scheduled to shut down or not, so that we can keep our etcd quorum. I know that was packed full of a lot, so I'm happy to slow down here and take questions.
Where does this concept of quorum come from? Mathematics or physics or what?
Mathematics. It's written, so etcd is written on what's called the RAF consensus protocol, and there's a whole paper out there about it. But yes, it is based. There is a whole theory around it.
Thank you.
So that's the extent of my demo. Really just showing off plugins and showing the transition from how we traditionally think about Unix and what we could do when we have structure, we have events, and these things behave more like controllers, and humans become, as we all know, humans are always the problem, right? When you have a machine that a human can hop on, and especially in a clustered world, in a distributed world, you need consistency because you are talking about clusters that potentially have thousands of machines that are part of that cluster. And a random engineer hopping on and making this machine a snowflake compared to the others, you're going to be scratching your head for some time wondering why. And so the idea here is we're going to just lock humans out, and we're actually just going to have everything be API driven. And I will stop sharing. That's the demo.
Thank you.
Really interesting. Thanks.
So is there then no possibility of interfering and having shell access to go in and tweak something?
That is a good question, because there is nothing stopping a user from, say, scheduling a container on a node. And actually, if they have root access, Kubernetes does allow you to mount up arbitrary host paths into the container. And you very well could set up a container that has SSH and has all of the things mounted up from the host into the container. But that's where we're getting into, I guess, more specifics. Just to extend on that a little bit, and COSI is not necessarily meant to address that directly. Talos, the operating system that we are creating, we are building it on top of COSI, and we are aiming to address that. We are going to refuse mounting up host paths, for example. Talos runs completely in memory. It's a squash FS, and it is completely read-only. And so it's ephemeral. It is immutable. And so there's really not a whole lot that the user can do, even if they do get access to the host. Everything must be driven through the API. So I hope that answers your question.
Yeah, thanks. Good.
Are there any resources we can refer to get more information?
That was very low, but I think I heard, is there any resources we can refer to for more information? I didn't hear that last part, but I think that's what it is. I'm almost certain.
Yes, I'm sorry. I had my mic up.
No problem. Yes, I will post a couple links. I'll start with the COSI project itself. In general, we have a GitHub org that you all could look at. If you are interested in a more fleshed out, distribution, I will also post a link to our distribution called Talos. I posted those in the chat, by the way.
Thank you.
Yep.
Thank you. I may have missed it before, but did you talk about licensing or this copyright, copyleft, whatever? How, down the road, is there going to be any kind of, is this all open source kind of, or what?
Yeah, absolutely. 100% open source. And we are aiming to be as free from all the GNU drama that we possibly can. And we want this to be real, true, free open source software for people to use. Licensing, we are still working through that, because the fact that we actually potentially could be linking against the Linux kernel, there are some interesting licensing things there. But in an ideal world, I think we would be looking at something like the Apache 2 license.
That sounds great to me, I guess. Not a lawyer.
I am not either, and I will put that out there here.
So, like, kind of along those lines, like, where do you guys need the most help right now? Or where it sounds like it's still developing, but, if somebody wanted to get involved, how could they do that?
Yeah, I would say that really depends. If you have programming skills, hop on, try to create a plugin. I mean, right now I'm creating a plugin for mounts and DNS resolution. Think of any other number of utilities out there that we could replace with this. I can't think of any off the top of my head because I'm not good at being put on the spot, but I'm sure you can think of many of the utilities out there that we use today that you can translate into an operator or a controller. I'd say that that's one place. We also have community meetings. And just getting general feedback, like, is this something that you think is valuable? What would you like to see from a system like this? Where are we going wrong with this? Just as from even an architectural, philosophical point of view, even, technical writing. If this resonates with you and you're a great writer and you may not want to program, just getting our message across, I think, is going to be very important. Because one of the things that I personally fear is that I have a lot of respect for where we've come from, right? Unix is, I mean, I say this in a blog post somewhere, but Unix, just the fact that it's still around really speaks to the power of it, and to the simplicity and the minimalism behind it just speaks volumes. So I do want to, keep that in mind as we go through. And so kind of forget where I was going about this because I'm excited about just people inquiring. But I think where I'm going with this really is, there's a number of places, technical writing, just checking our thoughts against you. Does it make sense? There's a number of ways that you could really get involved. So I'd say pick your poison. Stephen, I don't know if you have anything to add, but that's all I have.
Yeah, I think we have community meetings. There's a lot of design things. I think feedback on use cases, right? Like we really want, the idea is really, we're trying to limit it right now because I think general purpose operating systems are really complex. So we're trying to keep our scope narrow. But if you have that kind of use case where you want to run you know, firecracker VMs or containers. That's kind of the use case that we're really trying to get, and something that's highly configurable, very secure. I think Andrew didn't get to that, but like we really want to have like one of the most secure operating systems that's possible. You know, that everything's in memory, that it's very durable, it's hard to break into, it's hard to break. Those are kind of the goals that we have. So any kind of feedback that you would have in your desired operating system, we would love to hear about, or how you'd even interact with it.
Would you find the community through the GitHub links or what?
Yes.
Thank
I will
you.
actually find a link for you now. And I did remember what I wanted to say is what I think for the success of this project really depends on getting, how do I say this in the most politically correct way possible? The people that have been doing this stuff for years and years, longer than I have, right? I don't necessarily want to step on their toes because I know that this is a different way of thinking about Unix, and that's why I want to stress that we look at this as an evolution. And so one of the ways that you could help too is just, you know, how do we communicate this message to the people that have been doing this for, how do we get them to accept this and have them understand why we're doing this, so it doesn't feel like we're just throwing out everything that we've been doing for years, because there's always that argument of why reinvent the wheel, right? We're really not. We're just taking the wheel and we're evolving it. We're adding rubber. We're adding tread. We're actually doing, you know, statistical analysis on how effective we are in rain. I know these are really bad analogies, but I just really want to drive the point home that we are really just interested in evolving this, and we could use help even in that aspect. Is just, you know, is our messaging correct even? Oops, let me mute.
Yeah, I had my cat visit before, so very interested in the presentation as always. So I take that as a good sign. You know, getting cats interested in anything, especially technology, is very hard.
I'd like to point out that throughout all this, you've had at least the low point is 19 or 18 participants. I mean, a couple people have left because it made their brain bleed, but there's a lot of people that really stuck around because they have found it very interesting, and the participation has been great. Oh,
that is
very
awesome.
interesting.
Great.
Yeah, I'm very excited about this stuff. I think it's awesome. So it's one of the most fun things I've ever worked on. So I think it's.
And I kind of love the way. Oh, I'm sorry. Go ahead.
No, go ahead, Gary.
I kind of love the way you tied it back historically. The beginning days of Unix, the movement from Multics to Unix, and of course, one of the aspects of that was the concept of in Unix of, okay, let's just build little tools. You know, we build a tool once and then make it available, kind of harkening back to our beginning talk tonight about functions. You know, it's like, okay, you just make all these little tools, all these little functions, you can call them, and you know, they're a done deal. You know how they work. They always work that way. And when I mentioned serverless, for those of you who aren't familiar with that concept, of the Amazon, Google, Microsoft, they all now have set up their pricing structure so that you know, it costs a certain amount of time and effort to start up a program and get it running, and then you know, you get billed for whatever time, and then it gets torn down. Well, if you can write something that is tight, you know, small, you know, and it runs in a very limited amount of time, they started realizing it's not worth their time to try and track billing on that. So basically, it's a freebie, and it's what they refer to as serverless. And so, yeah, now it's become a thing for major corporations to write little serverless functions because they don't get billed for it. And it's right along with the old Unix philosophy of, yeah, just make a small, simple tool, reuse it, have it available. And that's why when Andrew mentioned plugins, that's what came to my mind. Oh my gosh, the plugin is just crying for, ooh, make me a serverless, and I'm not billable that way. It's
yeah. Yep. No, that is interesting. I definitely will keep that in mind as we go through it. I have to admit though, I think COSI is really built for the Amazons that are building their serverless function infrastructure, if that makes sense. We're sort of a step just below that, if that makes sense. But I mean, hell, if we could figure out, excuse my French, if we could figure out how to make this work in a serverless world, by all means, let's do it.
Yeah, and one use case there, we talked about it, like, but the engine underneath Lambda is something called Firecracker, which is designed for really low-level VMs. And there was just a blog post out that was really interesting that by this company called Fly that took basically Docker images and converted them to like low-level VMs on the fly running in Firecracker, right? And they had their own PID1 that they injected in it. So you could think like a future Kubernetes workflow or like a future COSI workflows that like you just run these really small VMs, very short amount of time. You convert these OCI images on the fly, which is what the Docker standard is. So there's like a lot of really interesting things there you could do. Once we get the operating system to be really API centric and designed to run these other kind of isolated workloads above, which is what we're thinking about.
Steve or Andrew, whichever, KubeCon, if I remember right, the date for that is, I want to say May the 20th. Is that?
May 4th to the 7th.
May 4th to the 7th. Okay, that shows you what I know.
It's all virtual. Yeah, this was originally supposed to be, as I said, our practice talk for it. But
and KubeCon.
This is way better than the practice talk, because the practice talk, we had to get it within like 25 minutes and we practiced it for a weekend and had recorded, and it was just kind of a miserable experience, where this is like chatting with people is actually really fun.
Yeah, this is a blast compared to that. I mean, it is a blast in general, but yeah, even more so compared to that.
Is there a registration fee for KubeCon? Is it open? Do we get to register tomorrow or day of, or tell us a little bit about KubeCon?
I think Stephen's looking it up, but I can speak real briefly while he's doing that. It is registration, and just a heads up, this is an EU. So I believe I will be sitting there watching myself at 3 a.m. in the morning and waiting for questions after. So I don't know if it's accessible for the US folks, unless you're very early risers. I'm on the Pacific Standard Time, so maybe, well, you guys are all St. Louis, sorry.
Yeah, I work nights, so that works.
All right, perfect. But yeah, it is, I'm sorry?
I'm old and I can't sleep.
All right, then. Hey, we'll see you guys there then. But it is, yeah, Stephen just posted it.
It's like $75, so it's really reasonable. If you've been to any real conferences that are hundreds or thousands of dollars, so. And all the talks usually are put on YouTube within a few weeks. So if you just want to wait,
yeah, good point.
I think our talk is one of the oddest ones there, though. So it's really interesting that we're introducing this. So I'm pretty, I was looking at the other talks. I'm pretty excited about ours.
I love the fact that your opening slide, or your second from the opening slide, was that 9960. Now, was that it wasn't a CDC machine, was it?
I don't know what it was, but some of the graphics there was from the Pascal community, because I've been doing I read like Pascal newsletters, and I recognize that logo because that was actually like a consulting company for Pascal, that 2999 or something like that. So I've seen it before. This is far.
If those disk packs were anything like I worked with in 1985, they were 400 meg apiece. That's a CDC machine. Yeah, I do believe.
The 2966 Model 39, whatever that is. So.
Yep.
So for the last couple of months, this group has sparked off into having little side discussions about, we're going back to the old days. There's always been this yin and yang of mainframe, only now instead of calling it mainframe based, call it cloud based, versus the desktop or the user. Where's the data stored? Where's the computing power? And yeah, we've definitely, we're heading back towards that centralization. We call it the cloud now, but yeah, it's basically not a mainframe, but a rack of servers. And it's somewhere out there. And for some big corporations, you own it. Yeah, and some of us have thought, okay, this is only for only big enterprises put stuff out in the cloud. And now we've realized that small businesses are now putting stuff out in the cloud, and it's now the price points come down to is there any point in any of us as individuals going out and buying that extra expensive desktop or laptop system with a lot of extra memory and CPU in it? No, all you really need is a graphic device and a network connection. And for a lot less money, you can actually spin up an instance out in the cloud and do all of your heavy computing out there, and just have a little local, virtually a terminal.
Yeah, but can you play Doom?
I hear that, and I raise you Parlor.
Ooh.
Yeah, own your own infrastructure, folks. It can help. Also, can I hook up a old thin terminal and connect to it that way? Probably you can.
Yeah, I'm sure. I don't know how the Getty devices get kicked off. We'd have to. That's in a init tab, isn't it? I'm trying to remember how they get. So we don't have an init tab on the system, so maybe not. Or system D. I don't know. Just thinking about how it all kicks off in the past. Well, that's all I had. I think we're getting close to 9 o'clock. So.
Any other comments or questions for our speakers this evening? I think it's really been a great presentation. You've opened our eyes up to some new ways of thinking here, and yeah, it may be the wave of the future, or at least part of the wave of the future. So.
I think something like this is going to become the way like server Unix runs in the future, pretty much. Like if it's not this, it's going to be something similar to this. Like a really isolated API-driven operating system will be kind of the future of server Unix.
Great. Well, fantastic. Unless anybody else has any other specific questions or comments for Stephen or Andrew.
And we are inviting people to do any kind of comments or questions on the discuss list that we maintain, and if possible, we might forward them on to Stephen and Andrew. Fire in a hole.
Awesome. Well, thank you everyone for having us. That was a lot of fun.
Well,
thank you.
I
I
really enjoyed
learned
it.
a lot.
And we'll if our speakers need to run, we understand. If you care to stick around, like I said, I think we'll just let the group continue on here and just kind of have some general chit chat. And back in the old days, we'd start putting beer and pizza in our mouths. But
I wish I could stick with that, but yeah, I got the kids looking at me. They're foaming at the mouth, hungry. So I better go.
All righty. Thank you very much, Andrew. Really appreciate it.
Thank you. Take care, everyone.
Good evening, everybody.
And maybe we'll leave the recorder running for just a little bit. And so if anybody has any general questions or comments that not mind having on the recording,